Hey guys, it's Mr. C. In this video, we're going to talk about fitting lines to data. So, if you are given a scatter plot, which is what this is, and you are asked to estimate or find a line of best fit without using technology, the best thing you can do is probably to take a ruler and figure out what line of best fit would split all of these points best. Now, technology will be able to give you that exactly, but if you're just looking at it and you don't have any technology, then you're just going to have to make an estimate. And so an estimate is probably going to be close to the computer anyway, but it won't be exact. So here's what we're going to do. We're going to look at these dots here, and we're going to take our ruler and we're going to make a line that we feel comfortable at splitting that data as best as we can. So what I'm going to do is I'm going to take, and this just takes some practice, but if I start here, and if I go all the way up to this dot right here, like this, does that line split the data pretty well? Do these dots are they as far apart as these on the other side altogether? It's not bad. We got two dots that are almost all the way on it, not that that matters. This dot's kind of far off, but then this dot's a little further off, and these are also. So I'm okay with that line. It's not going to be perfect, but it's not too bad. All right, so what we're going to do is we're going to find the slope and the y-intercept in the equation of each one of these. All right, so the slope of this line is going to be basically rise over run. So to go from this dot right here to this one, which is 14 units over, it goes up 1, 2, 3, 4, 5, 6. It goes up 6 and over 14. So that's our slope. Generally though, for our equation, we usually put a decimal in for that. So if you get the decimal equivalent of 6 over 14, that's about 0.4286. And you can just put that in the calculator and it'll give it to you. The y-intercept of this line that we made was 1, 2. So just positive 2. So now if we want to make the equation of the line for this line of our best fit that we think is probably best, we would simply write y is equal to the slope 0.4286 plus 2. And that's our line of best fit. And it'll probably be pretty close to the one that you do in the computer, but that's all it asks us to do, estimate. All right, let's do number 2. Number 2, this time we want to again split these points as best we can. So what if I start here and I go all the way down to this one? That one appears to split it decently. So we're going to go from this point to this one. Okay, and our slope then would be negative 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 over again the 14 total from 0 to 14. And that's going to give us a decimal of about negative 0.5714 if you put it in the calculator. The y-intercept of this line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then our equation is going to be y equals negative 0.5714. Oh, and I forgot to put the x on here. My fault on that. My bad. X plus 10. Yeah, I can't really forget that x right there, and I did. So my fault. But there's supposed to be an x right there after the slope. All right, hopefully you caught that before I did in my video. Let's try number 3. Number 3, we're going to do the same thing. I'm going to estimate that. This is pretty strong positive, by the way. So I'm going to estimate that to go from here to about here. Now, how do I know to put my line on these dots? I don't know. I mean, it's pretty close. Experience kind of helps, but I mean, that splits it pretty decently. You could have probably gone up to here, this dot, if you wanted to. I chose not to. It's not really going to change it too much. But our slope is going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 14 again. And that's going to simplify to 0.7143. Our y-intercept this time was 1, 2, 3. And that's going to give us the equation y equals 0.7143. Don't forget the x, plus 3. And then number 4, same thing. I'm going to go ahead and start here. It looks like it's negative here, and then I'm going to go up to this one right there. Let's just make sure. Let's see. That one looks pretty good. Okay. That looks like, I mean, that doesn't really split it very well, does it? Let's try another one. I don't like that. Let's stay here, but now let's go down one block. That one looks a little bit better. Now I have more dots up above than I did before, and I'm gonna get rid of that one. Okay, so we're gonna go from this dot to this one. So we're gonna say ignore that because I used a pen. All right, so the slope this time is gonna be 6. It goes up to 6, so 1, 2, 3, 4, 5, 6. But it's really, to go up and over, it really is just a rise of 4. Or I mean, down a 4, so down 1, 2, 3, 4. So minus 4 over 14 again. And in the calculator, that's gonna give us negative 0.2857. Our y-intercept this time is 6. Kept saying 6, but that's the y-intercept. The equation then is going to be y is equal to negative 0.2857x plus 6. All right, so those are 4 problems with fitting lines to data on the EOC. Sometimes they will have you do that. And this is what the EOC item will more than likely look like. So we have for ours, it says, Kelson surveyed 25 people and recorded their age and the average number of text messages they send per day. He put his data into the table below and then made a scatter plot. So there's our scatter plot right here. Here's the data. And so part A says, circle the most appropriate equation below that Kelson should use for the line of best fit on the scatter plot. Let's see if we can see that. Okay, so which one of these is going to be the most appropriate equation for the line of best fit? Okay, so if we look at these, let's look at 0.6x plus 34.5. Our line of best fit has to have a negative slope to it. First of all, it's got to be negative, right? And so if we look at our answers, anything that doesn't have a negative slope needs to be eliminated. So this one doesn't have a negative slope. It needs to be eliminated. This one has a negative slope. This one does too. This one does not have a negative slope. That one needs to be eliminated. This one does, and this one does not. So just on the fact that it has to have a negative slope, 3 answers got eliminated. The other thing is the y-intercept of our line has to be positive, right? And it's probably going to be around anywhere from 30 to 40, I would think. So if I look up here, this one has a negative 34.5 for the y-intercept. It can't be that. So that one fails just on the y-intercept. This one has a y-intercept of 25. I really don't think that 25 is going to be it, but you never know. Let's hang on to that one. So we'll put a question mark there. And then we have this one over here, this 34.5. I like this one better because I'm thinking that 34.5 is probably going to be the better y-intercept rather than 25.0. So to me, what I would do is I would say, okay, this one's probably not going to be as good. This one is a little steeper. That one looks better. All right, so now how do I graph? It says part B is to graph the line you selected above on Kelson's scatter plot. So how do I graph this now? Well, how can we do that? Negative 0.6x plus 34.5. Couple ways we could do that. We could pick some ordered pairs, okay? And we could see what the values would be for the x and y values, the order pairs, to actually plot. So first of all, let's look at the x-intercept. Okay, when when y is 0, we get the x-intercept. So let's do that. 0 is equal to negative 0.6x plus 34.5. Okay, so negative 0.6x plus 34.5. If you move the 0.6x over this way, you get 0.6x plus 34.5. And remember, we made y 0, so we know that y is 0. Okay, so if we solve this now, let's see, 34.5 divided by 0.6 is 57.5. So we are looking at the ordered pair for this one, 57.5 comma 0. That's the x-intercept. So 57.5, 0. This is 55, 57.5 would probably be about right here. Okay, so right there will be our first order pair that we could graph. We have an issue though, because we can't use the other intercept because it's way up here, 34.5. We know it's gonna be way up here. So we need something more in this range. So let's say when x is, what do we want x to be for when y is, I don't know, 30? Let's see what happens. So when y is 30, so this one's when y is 0. When y is 30, we get 30 is equal to negative 0.6x plus 34.5. All right, so if you subtract 34.5 from both sides, we're going to get negative 4.5 equals negative 0.6x. If we now divide by negative 0.6, okay, so now we can do 4.5 divided by 0.6. We get 7.5. So what that means is that when y is 30, which is what we set it as, the corresponding x value is 7.5. So we now have the ordered pair of 7.5 comma 30. Okay, and this takes a little bit of experience to do too. And they know that on the EOC. That's why they make these kind of hard. All right, so 7.5 would be about midway between 5 and 10. All the way up to 30 would give us about that point right there. Now those look pretty good, because if I graph this line between these 2 points, that's a pretty decent looking line of best fit. That's not bad. And if you use technology, actually that would be very, very close to the actual line of best fit. And so I'm pretty confident with that answer right there. All right. So there you have some lines of best fit. And so that's 4.9. So remember to like my videos, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.